Great work! Now we will learn about the main machine learning steps. As you've learned previously, supervised learning predicts a certain outcome. We typically follow 5 steps when building a supervised learning model. First, we split the data into training and testing. This is important as we want to train the model on one set of data and then measure its performance on unseen values or testing dataset to make sure it works well on unseen data. Then we initialize the model. After that, we fit the model on the training data. Here, we also say that we are training the model. Once that is done, we predict the outcome using the trained model on the unseen or testing data. Finally, we measure the performance on the testing data. Let's see how this looks in code. We will build a supervised learning model using a simple model called decision tree, which is basically a set of if-else rules which decide what is the predicted outcome. First, let's load the libraries we will need. We import the tree module from scikit-learn, then the train-test-split function to split the data into training and testing datasets, and finally, the accuracy score function to calculate the model performance. Now, let's build our first model. First, we split the data into training and testing. We use the previously loaded train-test-split function, which requires the original x and y datasets, and a test size parameter value between 1 and 0. This defines the percentage to be reserved to testing dataset. Then, we initialize the decision tree and store it as myTree. The next step is to fit the model on the training data. Here, the decision tree learns the if-else rules, maximizing the model accuracy. Once that is done, we predict the values on the testing dataset. Finally, we calculate the accuracy score, which is the percentage of correctly predicted outcome variables. In contrast, unsupervised learning aims to group the observations into mutually exclusive clusters. Here, we have fewer steps as there is no target variable and no need to measure model accuracy. First, we initialize the model, then we fit the model on the data. Once this is done, we assign the cluster values to the original dataset. Finally, we explore the differences between clusters. We will now build an unsupervised learning model using a very popular model called k-means clustering. First, let's load the libraries we'll need. We import the k-means module from scikit-learn library and the pandas library. Then, we initialize the k-means instance with one mandatory parameter, number of clusters. In Chapter 4, we'll go through several approaches how to find the optimal number here, but ultimately it's a test and learn process. The final decision is made in Step 4 when exploring the characteristics of each cluster and choosing the solution that is the most interpretable. Here, we initialize the instance with 3 clusters. In the second step, we fit the model on the data. Next, assign the cluster labels to the original dataset as a separate column. Finally, we explore the clusters by aggregating the original data for each cluster. In this case, we calculate the average of each variable for each cluster. Impressive! Now let's go and try to implement some of these models.